Hi, we're going to look at database design in this module, and it may seem a little bit unusual that we have already seen how to create database structures, have gained some familiarity with a database management system, have learned how to query data with SQL, but I think that having had that experience is going to make designing a database that much easier to understand, and you'll have a much clearer understanding of where the design process is leading. So again, it seems a little bit backwards in the sense that there really can't be a database until the database design is conceived of, and that we can't really do any of the things that we have done until the database exists. But nevertheless, you really need to have some kind of background, because to present database design without your having any clue as to how a database works, or without having any clue as to how you can retrieve data from it, I think would be very, very difficult to grasp the material. So we're going to look at a database that I designed a few years back for instructional purposes, and this actually occurred to me when my daughter was starting college, and like all good dads, I got out my credit card before classes started and headed for the bookstore. And when we arrived, the bookstore had just undergone a change in ownership or management, and when we walked in, it was completely different than the layout was completely different than what it had been previously. No longer were there stacks of books out in the open where students could look at the books and pick and choose among books that were used and books that were new. Everything had been moved to a back room, and there was a store attendant that would take the book request from a window and go back and fetch the books off the shelf for you. And so it was very difficult to do any kind of comparative shopping, and I was a little unhappy because as a parent, I want to spend my money wisely, and if there's the possibility of buying a used book or buying books online, I certainly want to take advantage of the best price. And the barriers that had been erected made it very, very difficult to do that. So I thought through what an ideal situation would be, and I also took into consideration a book buying consignment operation that one of the student organizations on campus had going on during that time. It's no longer in operation, but at the time there was a particular organization on campus that more or less competed with the bookstore operation, in that they would collect books from users and then sell them on consignment. And so I thought about the entire operation that existed, and also considered that there was a bookstore operation on campus that could compete with the bookstore, and thought about how I might design a database that would facilitate students and facilitate the organization's book selling operation. So here's how I proceeded, and this is an approach that's used, or at least similar to other approaches that are used in designing a database. So this is a pretty good representation of how one might go about examining a real-world problem and eventually designing a database and building a database to store the data to solve that problem. So what I did initially was I created a narrative that described the environment in which the problem existed, and I tried in writing this narrative to be very careful in the nouns that I used, and tried to avoid pronouns and synonyms. So this narrative will be available to you. So I'm not going to read it to you on the video, and I'm not going to, pause the video long enough for you to read it probably. But if you're able to listen to me and read this very quickly, all the better. But you will have a chance to pause the video, go read this if necessary. So in writing this again, I was very conscious of the nouns that I used in the narrative, and tried to avoid pronouns, which meant that I would repeat the same noun over and over again, which may sound a little awkward and wouldn't necessarily be the way I would develop a narrative for other purposes, but I wanted to be careful in the way I phrase things, because once this narrative has been written, and once I have chosen the nouns very carefully, then the next thing I do is go right back to that same narrative with a highlighter and try to highlight what I think are the significant nouns in the text. And these significant nouns will eventually give me some insight into what tables and what columns need to be included in the eventual database. So this idea of going into a real-world environment and creating a database is not a real clean process. There's no real straightforward way that I can say, oh, you do this, you do that, and after steps 1, 2, and 3, the database is done. It's not that simple. When you design a database, you have to really do a lot of exploring, and you need to go into the environment. You need to observe the documents that are currently being used, or the documents that, if it's a new system, a whole new system, documents that are being proposed. You need to have lengthy discussions with the users and other stakeholders, and document your experiences very carefully. And again, at some point, what you want to do is distill the nouns from the environment, because they are the things that you will eventually include in your database. They are the things about which we need to store data. So by not using pronouns as I created this text, you'll probably notice that, for instance, the word student appears multiple times. Student or students appears multiple times. Likewise, textbook or book. Okay, so sometimes the noun, the form of the noun will change ever so slightly, and I see instructor occurs frequently. So again, by not using pronouns and allowing these same nouns to surface over and over again, just the frequency at which a particular noun occurs in the text gives some insight into how significant it is. So one of the things I do is very quickly scan it and say, oh, that noun's happening over and over and over again, and that's going to be related to the issue of storing data, so it becomes automatically a candidate for eventually using in my database design. So I have created this narrative. I have harvested the nouns from it, and this probably is not going to be all the things about which I want to store data, but it's a starting point. It gives me a sense of direction, and then once I begin using some of these nouns that I harvest from the text, other things will occur to me. So I have identified the major nouns, and those nouns will eventually represent entities or attributes. Okay, so in your lecture outline, I indicated what an entity was, what an attribute is, and understand that entities will eventually become tables, and attributes will eventually become columns. So as I am identifying all these things about which I have to store data, then I am really setting the stage for identifying entities and attributes in my design. Alright, so once I have done that, the next step in the process is to begin building a model. And the modeling technique that I'm going to use is the one that's most generally used. It's called an ERD, or an entity relationship diagram. And it will look very similar to a relationship diagram in an actual database. So here I am, I'm sitting down with a sheet of paper, and I'm trying to figure out, okay, what exactly do I want to store in this database? What are the tables? What are the relationships? And at some point, after looking over my list of nouns that I've distilled from the narrative, I say to myself, well, I'm gonna pull out two of these that I think might be sharing in a relationship, and I will make a sketch of them, and I'll try them out for size. So in the first iteration, and I want to call your attention to the fact that this is really an iterative process. There's no such thing, at least I don't know of anyone, that can design a database and just say, okay, here's my list of nouns, yeah, I see it, and immediately, work up all the tables and all the relationships in sort of a linear fashion. It's not likely to happen. I don't know of anyone that can do it. So a more likely scenario is you begin, much like putting a puzzle together, and say, okay, here's a couple of potential entities, and let's see if they fit together in a relationship. So as I consider an instructor, in my mind I'm thinking of a human being who stands up at the front of the class that supposedly knows more than the students and gets paid to tell them things. And then I also have this thing called a title, which is not going to be quite as clear to you. But after I had given the problem some thought, it occurred to me that there's really two aspects to what we think of as a book that I need to be storing data about. I need to store data about the sort of the proprietary aspects of the book, what we think of as the title, the edition, the publisher, the ISBN number, and I need to store that away. And then I also need to store away the physical data about the physical aspects of the book. So if I have 3 copies of Gone with the Wind, then I might want to store away the fact that Gone with the Wind is fiction, and Gone with the Wind is a book that was written in 1930 something, and might want to store away the fact that it's 750 pages long. So these are kind of the, I guess, the intellectual aspects of the book would be the better way to describe it. The intellectual aspects of the book. But I also have these three things that are sitting in front of me, both the same size, or all three the same size and the same shape, and one is still in shrink wrap, and another has been dropped in a mud puddle, and the third one the dog has chewed the cover off of. So I have these three physical objects, and each one of them has some physical characteristics. One's in good shape overall, one's in bad shape overall, and one is in very bad shape overall. And it might be that I want to estimate the price for each one of them. So the one that's still in shrink wrap is going to have a dollar amount associated with it. In other words, a column of data or an attribute regarding its price that's going to be different than the attribute that is associated with price for the second and third one. So I have the intellectual data that I want to store about the book, and I have the physical data that I want to store about the book. And so what I'm going to do is treat the book as if it is two separate entities. And I'll have an entity that relates to the intellectual aspects, and I'll have another entity that relates to the physical aspects, and I'll call the entity that relates to the intellectual aspects title. And I'll call the entity eventually that relates to the physical aspects book. So just hopefully that makes that clear. So here we are, the instructor, and I'll probably use these terms kind of interchangeably as I describe things. But here we are, we're thinking about, okay, if I take a particular instructor, let's say Chuck Kuntz, how many titles could Chuck Kuntz be associated with? Well, maybe I use a particular book in my CS1 class, and I use another book in a CS2 class. Again, more properly in our terminology, I use a title in CS1, I use a title in CS2, and I use another title in the database programming class. So that one instructor could use many titles, and that's what that N represents there in the relationship. If I put that instructor away and come over and yank out a book, book ABC, I don't care what you call it, but we pull out a particular book, a particular title, and I ask myself, how many instructors could that title be associated with? Well, if it's the title that's being used in the CS1 class, there's actually two sections of it, and so the title could be associated with Professor Kuntz, and the same title could be associated with Professor Parker. So in general, one title could be associated with many instructors, and I've got a problem. And the problem is that when it comes time to implement this in a relational database, I cannot directly implement a many-to-many relationship. So, I'm still in this discovery process, and this is not at all uncommon, especially when you first begin the process, to say, oh, that's not really quite, the way it works or should work. I'm not seeing this quite right. So as I, take a break and come back to it, second iteration, it occurs to me that, well, maybe the relationship isn't between instructor and title, maybe it's between class and title. So for the moment, ignore this, all right? And I say it's iteration number 2. This is probably more like iteration 3 or 4. But for the moment, ignore that this exists and just consider that I have the instructor entity, the class entity, and the title entity? Well, we know what title, we know what instructor is, and you probably know what class is. Class is an instance of a course, okay? So it's the implementation of a course. And if I am teaching 2 sections of CS2, then there would be 2 classes in here, one that relates to the first section of CS2, one that relates to the second section of CS2. So again, I'm thinking now that maybe title and class are what naturally exist in a relationship. And so I consider what that would look like. So I have an instance or a section of CS2, and I have the title Gone with the Wind. All right, so I pull out a particular title, Gone with the Wind, and I say how many classes could that potentially map to, and the answer would be many. So I put the book away, I come over to the class entity, and I say, if I pull out an instance of that class, so I'll just pull out CS1, section 1, how many titles could that class be associated with? Well, I'm sure you've had the unfortunate experience of having to purchase multiple books for a single class. So the answer to that question is many. So it turns out that, well, this relationship that I'm thinking between class and title is a many-to-many relationship too. And what am I to do? Well, I really think that I'm onto something here, that my original thinking of the relationship between instructor and title was not correct, and I believe that class and title is correct, but it's in the real world a many-to-many relationship. Therefore, I'm going to decompose it. And how I decompose it is this. I'm going to create another bridging entity, and this will eventually lead to what's called a bridge table or a junction table. But I create another entity that is, at least initially, going to be used to store the primary key of this table and the primary key of this table. So I'm going to create a one-to-many relationship from title to this new entity. I'm going to create a one-to-many relationship between class and this entity, and I'm going to name this class BR as in bridge, class BR title. And in doing so, I will have to store the primary key of class as a foreign key in class BR title. I will have to store the primary key of title as a foreign key in BR title. Class BR title. Class BR title is the child table with respect to both of these tables, so it's going to store 2 foreign keys, and if that is all I want to do, just create a linking mechanism, then I only need, at a bare minimum, 2 columns, the foreign key from title and the foreign key from class. Now, you may be wondering, well, what about the primary key for this? If this is going to eventually become a table, doesn't it have to have a primary key? Yes, it does, but if I'm just really dead set on only using the minimum amount of linking structure necessary to make this work, I can take the 2 foreign keys and treat them collectively, known as a composite primary key. I can treat them collectively as a primary key. So the 2 columns, the 2 foreign key fields that I copy over are going to do double duty. Individually, they act as foreign keys back to their corresponding parent tables. Collectively, their value can be used as the primary key to identify one row from all other rows within this table itself. So if I have a structure that is purely designed for the purpose of decomposing a natural many-to-many relationship, I have what's called a bridge entity, eventually, then when it's implemented, a bridge table. Again, sometimes you'll hear the term junction used instead of bridge. Junction entity, junction table. So I'm going to continue to call it bridge from this point on, though. So what I've discovered in designing databases is that when this happens, it's usually a heads up that there may be some other attributes that are not immediately apparent that should be included in here. And so as I think about this relationship having now been decomposed, I say to myself, anywhere a class is associated with a title, I may want to store some other things. For instance, I may want to store whether or not this this title is actually required for the class or whether it's optional. So I may want to add another column here, a true-false column called required, and denote on every row whether or not the class that's being associated with the title requires the title, whether the title is required for every class. So a very natural thing to do would be add additional columns. And when that occurs, when the entity begins to store additional data that occurs at that junction or that intersection between these two other entities, then this thing takes on a new life and is oftentimes referred to as an association table. And I, in fact, even used that terminology when I said that a title is associated with a class. Okay, so by introducing additional columns, I'm going to be really expanding the role of this bridge entity to one that goes beyond that, and it's really an association entity. Okay, so we continue on, and again, I have a list of nouns that I have harvested from the narrative, and I would continue to put them together, and in a final design of this, it would eventually evolve to the point where I would see that an instructor can teach many classes, but a class is only taught by one instructor. Okay, now you may have exception to that. You may say, well, I've had classes that were co-taught, that were team taught. Well, under those circumstances, we're going to assume that there's an instructor of record, and that for official reporting purposes in the registrar's office and the bookstore and places like that, there's an instructor of record. And in fact, that's the way it's done at every place I've ever worked. So an instructor, again, could teach many classes, but a class is only taught by one instructor. And we already saw the relationship that evolved here between class and title as it was decomposed, and then eventually we created an association table, class BR title. Then there's this idea of the intellectual properties and the physical properties of what we think of as a book. And so as I introduce this book entity, it occurs to me that a book, let's yank the middle book out of my 3-book stack here, and that is the one that was dropped in the mud. And I can read the title. The title says Gone with the Wind. Okay, so that one book maps back to one title here. That's where the one is. If I grab the book on top, it's in shrink wrap. I see through the shrink wrap that the title is Gone with the Wind. That one book maps back to one title here. So the physical objects always map back to one set of intellectual data. And then if I put the book away and come over here and yank out a title, yank out Gone with the Wind, and that one title then could relate to the 3 books that I have, or in general could relate to many books. Pardon me, I'm still not over this cold. Getting better every day, but okay, I'm back. So hopefully you understand that relationship between the physical object and the intellectual object. And then we have student. As you recall, one of the things I wanted to do in this database design was to set it up eventually so that the student organization could use the database and compete with the bookstore, which I am unhappy with. And since the organization is running a consignment operation, they're going to be selling books, these physical things, for students, which are a lot like instructors in the fact that they are human beings. Okay, so the people that listen to the instructor, that sit in the many seats in the classroom, are all expected to make a purchase of a book and read from it, and at the end of the semester they're probably sick of the book and they want to sell it. And so if I take a particular person, pull out, Chuck Kuntz as a student or something, and how many books could Chuck Kuntz have on hand that he wants to sell to this, that he wants to sell through this bookstore operation, the student bookstore operation? Many. So that one student could sell many books, but if I take any book in there, pull out the copy of Gone with the Wind that's in shrink wrap, how many students would it map back to? Would map back to just one student. So a student could have many books that they want to sell. A particular book, though, will only map back to one student. Okay, so that's the general idea of how my database is going to be designed. Now, these numbers down here in the bottom add additional information about the nature of the relationship. So in general, the relationship between instructor and class is one instructor teaches many classes, that's the N. A class is taught by one instructor, that's the one here. So it's a one-to-many relationship, but these numbers down at the bottom are called cardinalities, and they describe the lower and upper limits on the relationship. So if I take an instructor, one instructor could teach 0 or many classes. Okay, so 0 if the instructor is in the, think of it as the instructor's name and whatever other information is in the database table here. But for a particular semester, that instructor may be on sabbatical and is not teaching any classes. And maybe the instructor has been hired strictly to do research or something and is not teaching. Okay, so there's the lower limit on what is possible in this side of the relationship between instructor and class. If I go to class then and look at the cardinalities associated with it, when a class is taught, it is taught by one instructor and it is taught by only one instructor. So again, an instructor may teach 0 classes, or an instructor may teach many classes, or if I look at the opposite way, anytime a class is taught, it must be taught by an instructor. Can't have the class without an instructor. We push that limit a little bit with online, but still you get an instructor. And then there's only one instructor for the class. Okay, so where have we come from here? Well, we started out by saying we're walking into the database environment. We're going to snoop around and ask a lot of questions. So we look at source documents, we interview users and stakeholders, and we develop a narrative of some sort. And then we eventually, when we're satisfied that we have described things in sufficient detail, and after we've maybe gone back and even verified the our understanding of things with the users again. So I want to point that out. That's really kind of the systems analysis side of all this, is that you typically don't do something once and move forward. You do something, go back and verify, maybe correct it, go back and verify. So there's a lot of, cycles that we have to go through to eventually get a properly written narrative. And then once the narrative is written, we go through and identify the significant nouns. Once we identify the significant nouns, we begin the process of trying to map those nouns into into entities in an ER diagram and connect them with relationships. And we know that we may have to move things around, we may have to introduce some new pieces to the puzzle. And as we do this, new things may be discovered. So for instance, there was really some discovery here. In the text, I talked about textbook and books, but it was, an insight that I got that allowed me to understand that I really should take what we normally think of as a book and break it down into two separate kinds of entities. And then, once this is thought through in sufficient detail, and perhaps we even add some cardinality information to make it even more clear to us and clear to the people that are going to design the database, then eventually, after going through enough iterations of this, we come up with a final design. And when the design is finalized and we've validated and verified and all the other things that go into it, we eventually build the database. And so this is the relationship diagram that came about from actually taking this design and implementing it in Microsoft Access. And as you can see, I've got a one-to-many relationship between instructor and class. I've got the association table here, and I did not include the extra field here. I should have for required true false required field. The other thing I should point out here is that when I created junction table like this, I had mentioned that you can combine the two foreign keys that you store and make what's called a composite key. Composite keys get to be a little messy, and the alternative then is, even if you are building a structure like this, is to go ahead and add yet a third field, that being a dedicated auto number primary key field, otherwise known in database design as a surrogate key field. So I would want to create a surrogate primary key, probably just to make life a little easier and avoid having to combine these two columns. But that allows this, what would otherwise be a many-to-many relationship between class and title, to be decomposed into two one-to-many relationships. And then we have title, the intellectual data, being mapped to the physical objects that contain that intellectual data. And then we finally have the students and the physical objects being mapped in this relationship. And that relationship diagram that you see is very, very much like the ER diagram that we had created previously. So that is a very quick walkthrough of the basics of creating a database. And the one thing that I did not point out, and what occurs here between our final version of the ERD and the actual relationship diagram, is a process called normalization, and I will talk about normalization in the next video.